This is on section 6.7, imaginary number I. This is just a little bit of a mind bender for Algebra 2. The concept here stems from what do we do if we have something like this, the square root of a negative 25. So we are all taught that there is no such number multiplied times itself that equals negative 25. That's a problem, right? So that doesn't equal that. So in algebra, we often, if you read the beginning of this section, they say very clearly that there are times when we invent different number systems. This is one of those cases. And there is a definition here that will make your life easier. The definition is that when we have the square root of a negative number, let's make it easy, that is equal to imaginary I, such that when we take I and square it, it equals negative 1. So that ties in here, that when we take this negative or this imaginary number and square it, the result equals what we have here inside the radical sign. So let me say that again. When we have a square root of a negative number, that equals I, and the square root of negative 1 is equal to I, such that I squared is equal to negative 1. That means that a negative r, square root of negative r, is equal to I, which is negative 1, times the square root of r. This sounds a lot more difficult than it is. We'll go to some examples here right on page 288, 289. The first example they give is the square root of negative 5. So this is a here. Normally this is impossible. So we say that we can take out a negative, so to speak, and we say that this is equal to this imaginary number I times the square root of 5. Similarly, if we had the square root of negative 25, that is equal to I times the square root of 25. Now this is equal to 5 times I, imaginary number I. Similarly, we could say, well, we have gone from having an imperfect square, a non-perfect square here times I, to having a perfect square of 25, 5i. So the c portion here is the square root of negative 50. So that is immediately I times the square root of 50, which is equal to I times the square root of 25 times 2, which is equal to I times 5 times the square root of 2, which is equal to 5i, I'm going to run out of space here, square root of 2. Okay, that's an I right there. So this is a little bit of a mind bender to begin with, but you'll really cruise through this fairly easily. Let's go to another portion of this in an example that makes it a little more, just adds one little flavor to it. It's example number 3 here. And this is the top of page 289. It says, what would happen if we had the square root of negative 4 times the square root of negative 25? Well, this is I times the square root of 2 times I times the square root of 25. That is equal to, excuse me, this is 4 over here. This is I times 2 times I times 5. Now, this is equal to I times 2 times 5. Now, remember, very important, that I squared is equal to negative 1. Remember that. That is up here as well. So we have I squared here times 10, which is negative 1, times 10, which is equal to negative 10. And that is the answer here. And again, you can follow that on the top of page 289. So let's continue with this. On page 289, let's just make this a little more difficult here. Example 4, where you would have 2. I'm having some trouble with my pen here. Let me pause this. Be right back. Okay, sorry about that. So I'm on page 289, and let's look at an example here of 2 over an imaginary number here. So we have 2 over 3i. How do we simplify? Well, remember that this is important. Remember, I'll circle this, that I squared is equal to negative 1. That is how we get rid of how we get rid of I. If we can have a situation where we can have I squared, that converts to a number, and in this case that number is negative 1. So if we have 2i, let me rewrite this, 2 over 3i. We can simplify this. Think of this in I in the denominator as a radical in the denominator, which we cannot have. If we can multiply this by a form of 1, which is I over I, then we can get out of this 2i over 3i squared. Now that is equal to 2i all over 3 times negative 1. Okay, because again, I squared, I'm going to drill this in, is equal to negative 1. Okay, so dropping down, this is then equal to negative 2/3 times I, which is similar to saying the same as negative 2i over 3. So we can continue with this, and again, as you guys know I like to do, think of this in terms of, let's take this one step further and say, well, how can we change this up again? Look at example 4, part B. Let's take 6 over radical negative 2. Well, two things here. One, that's a negative, or excuse me, that's a radical in denominator, and 2, that's a negative here inside the radical sign. So we now know that we can rewrite this as 6 over I rad 2. Now, rad 2 cannot be simplified any further, but again, two things are amiss here. We have an I in the denominator and a radical sign. Let's get rid of both, and let's do it by multiplying by a form of 1. So we know that if we multiply I times I, we'll get negative 1. We also know if we multiply radical 2 times radical 2, we'll get 2, but we have to multiply by the same thing in the numerator. So this gives us 6i rad 2 in the numerator. And down here, think a little bit. We have I times I have trouble with the dots here, times I times rad 2 times rad 2. Now think about this a little bit. This is equal to 6i rad 2. Now in the denominator, that's negative 1, that's 2. So in the denominator, we get negative 2. Now if we continue to simplify here, that is equal to negative 2, and be careful, negative 2 into that is equal to 3i rad 2, which is the simplification of that expression there. Again, two things. Can't have a radical in the denominator. We bring an I out. We can't have an I in the denominator. Now, one last example here. And we'll do example number 5 here. That's on the bottom of page 289, where we have the square root of negative 9x squared plus square root of negative x squared. So now the point of this is to show that we've been multiplying here. This is to show that we can add i's. So let's very quickly here. This is equal to I square root of negative 9x squared plus I square root of x squared. And you're all well versed enough to know that this is now I times, excuse me, that's positive because we took an I out. Sorry about that. This is the square root of 3x squared, of course, is 3x. And this is I times x over here because that's the square root of x squared. So this is, and generally speaking, we write in this expression, we write it in this fashion. This is 3xi plus xi, or this is equal to 4xi. And so what we show is that we can add imaginary number I as well.